Everything in the universe is made of tiny units called atoms. And atoms are so small they are almost impossible to see, unless you have one of these. Hi, I'm Nunzio Motta, and I use this special microscope to study the atoms. And to give you an idea of how small actually the atoms are, have a look at this. If you were to take an orange and magnify it so it was the same size as the Earth, the magnified atoms of that Earth-sized orange would actually only be around the same size as the original orange. So, how do we isolate tiny atoms so that we are able to see them? First of all, we have to take a sample that contains only these atoms. These could be the carbon atoms that make up graphite, the atoms that make up certain polymers, or looking at the properties of material like silicon. With silicon, for example, we need to heat our sample to 1200 degrees Celsius to clean the silicon surface of all the other atoms. And this preparation needs to be done in an ultra-high vacuum environment, an environment where we take away all gases, even air. This is because atoms in the air can attach to the sample and can affect the images while the microscope is scanning. So, how does this microscope take images of single atoms? It actually doesn't work like a standard microscope that uses lenses. Instead, it uses a needle like this to take pictures of the atoms. This needle has an extremely fine point, which is lowered towards the sample. It gets lowered until it is only a fraction of a micron away. Then, a voltage is applied to the needle in order to create an electrical current. And we control the distance between the needle and the atoms by controlling this electrical current. The needle then moves back and forth across the sample. And as it moves, measurements are continuously taken, allowing us to map out the shape of the atoms. And after the microscope finishes scanning the sample, we end up with images like this. Each of these balls is a silicon atom. They are arranged in a nicely ordered fashion, depending on the crystal orientation. Being able to image individual atoms is very important, because it gives us the possibility to understand better the structure of materials. And this means we can have a better idea of how they will fit together with other atoms when we are trying to create new molecules and crystals.